I've got the wasp model uploaded onto this Raspberry Pi here with a Neural Compute Stick 2 and the gimbal with its camera mounted on the top and a laser there. The laser's not actually plugged in, so it can't actually vaporize anything, and the rest of it there, it's a bit cluttered, lots of wires around at the moment. And on the Raspberry Pi computer we've got on the left hand side serial console output, which gives us a blob rate per second of 1.42, and on the right hand side we've got the actual capture frames, and in the middle of the screen is a wasp which is being output on this screen here. So if I move this computer around there, you should see the gimbal trying to track it, and there it goes, just slowly tracking around to follow the computer. I emphasise the word slow because, as I said, the blob rate here in magenta is quite slow with this model. There's actually something wrong with the way I've trained this model. The mobile SSD network is supposed to have 20 different object types in it, and I've just used one object, the wasp. So if I retrained it with 20 different types of wasp, or wasps and caterpillars, or wasps and slugs, or whatever, then it should work a lot better. So that yeah, the critical data here is the blob rate, which is the inference blob. I mean, I've got frames per second displayed there and detections per second, but it's not really that critical because those values are a lot higher than the inference blob rate, so not really relevant for this demonstration. But now let's compare what we've got here to the mobile SSD network when it's set up properly with all the 20 classes or objects that it's designed to detect, like birds, people, cars, buses, trains, etc. And to see by the inference blob rate that when it's trained properly, it works a lot quicker. So that's the next part of this video. So I've now uploaded this Python script for the proper mobile SSD datasets, and one of the objects included in the dataset is a bottle. So I've got a bottle in my hand here, and you can see it on the screen there, and hopefully if I move it, the camera will track the bottle around. It's not fantastic, it doesn't work, but it's a lot quicker than the previous model. You can see just by the way that the yellow box flickers around the bottle a lot quicker. And if you look at the blob rate here, we've got about 10 times per second, which is about 5 times as fast as my trained wasp model. So let's look at the gimbal moving around, following it. It's not moving too quickly. Don't want it to move too quickly. For one thing, it'll just tear itself apart. And there it goes. All around. So what it's trying to do is it's always trying to centre the bottle into the middle of the screen. So if I move the bottle to one side, the gimbal will then track so that the bottle centers. So, okay, yeah, it moves slowly. I could program the gimbal to move a bit faster, and the next demonstration uses the Squeezenet 1.0, I think, network to detect faces, and I've made the gimbal respond a lot quicker to that one. So let's upload that one. I've uploaded the Squeezenet 1.0 network, which is quite a lot older than the MobileNet-SSD network, and certainly seems to be a bit more efficient on this Raspberry Pi configuration. And so it's now set up for recognizing faces. So if I stick this cardboard cutout face here, there we are. I'm just moving that around in front of the camera. And you can see it on the screen. It looks a bit better on the screen, and the gimbal's actually able to respond really quickly to this because I've speeded up the gimbal a little bit. And if we look at the blob rate here, I don't know if you can see that on the screen. There it is. It's quite high. It's 18 frames per second, blobs per second, and the actual frame rate is about 10 frames per second. It's gone up to 17. So really the critical thing is the inference blob rate rather than the frame rate, and because the network's a lot more efficient, a lot quicker, and it's more accurate as well, I'm able to speed up the camera on the gimbal, so the gimbal tracks it a lot quicker. See, I can pull it away, there's very little delay, little shake. So yeah, it tracks it quite quickly, and there's not too much lag. And I think that's mostly due to the fact that the network is more efficient, which is interesting. So if you look at the face, it's quite basic. It's like a mouth, a nose, and two eyes, basically. So it's a relatively simple object to detect. And compared to the background, there's not a lot in the background which looks like a face. Everything else looks entirely different, especially that wasp. So wasp looks entirely different to a face. So if we've got objects which are easy to detect, we can use simpler networks, probably.